Welcome back. Welcome back. My name is Bradley. This time we're going over Lab 2. Lab 2 is all about instantiation of modules. We're going to be instantiating a half adder module to be able to join them together for a full adder circuit. It's going to look something like this. This is the schematic for a half adder with an AND and a XOR gate with two inputs. Now, the outputs sum and carry, these are going to go over to the module that we're coding, which will be instantiated twice. It's in this code right here. On lines 10 and 12, these are the lines where we call the half adder modules. And these are going to be the signals that will be connected to the ports. I'm going to go over the rubric here. The problem statement is to implement a full adder module based on the given half adder module. We can accomplish this by creating two instantiations based on this following circuit. Here will be the two instantiated half adders. Their outputs for the carry out will be up here for the OR. What you can see in the truth table over here will show you, and I will go over this when we're testing out the bit stream on the FPGA board. As for now, this is the expressions for the sum and the carry out, which I also have on my GitHub. So the approach to solving this problem is to call or instantiate the half adder modules correctly. And when we go back to this Vivado IDE, we can see that this is a really simple code because all it does is create a wire of 4 signals, and later on we'll be able to use these for the half adder instantiations up here. And finally, these are going to be the expressions for the sum and the carry out, which you could see from this page right under here. And the output of my design came out to be as expected compared to the truth table. I verified it at first by simulating using a test bench and going through each of these the time slots. I was able to verify that they indeed add up to the actual values for the expected outputs. And these are just the schematics as well as the synthesized design and the implemented design, which are not really the goal for this lab. But after this stage, we'll verify the cases. Since we have 3 inputs, 2 to the third power gives us 8 possible cases. And we're going to go through all 8 cases. According to my XDE file, the least significant bit would be my C, and then B, and then A, so that it would match with the truth table. So from LSB to MSB, CBA, and then as for the outputs, carry out would be the least significant bit, and sum would be the bit right next to it. So one more time, this would be C, B, A, and as for the output LEDs, we have the most right, carry out, and the one next to it, the sum. So I'm gonna go, just gonna glance back and forth. Maybe this should work better. So, first case, when all 3 inputs are zeroed out, we don't have any lights. When we turn on the first light here, notice that the sum is on, which is correct. Now we're going to turn it off and switch on B. When B is high, we have the same output as the previous, which is, oh, excuse me. When B is high, the sum is also high, according to the third case here. 0, 1, 0 for sum to be on. And when we have B and C on, you could see how it switched from LD1 to LDO, which matches with the fourth case. And I'm gonna switch these off. Now we're gonna test the case when A is on and only A, which is the third from right, which gives us LD1 on, and LD1 is the sum. Checks out. Now we're gonna keep A on and C on. Boom. Now that's gonna say LD0 high, right? Now flip C off and then B on. So we're gonna have 1, 1, 0, 1, 1, 0 to give us 0, 1. And the 1 is the LDO for the carry out down here. Now as for the last case, all 3 inputs are high, which would give us LD0 and LD1 on, which matches with the expected outputs. As for the outcome of this assignment, I learned how to properly instantiate code modules to be reused. This is really useful because if you're working with a large amount of codes and you have different modules for different types or different designs, you'll be able to call and instantiate them to reuse them over and over for your top modules and the other modules that you want to call them, instead of having to rewrite everything, which would waste a lot of time. And this would also solidify my understanding of how a 1-bit full adder works in conjunction with the half adder modules. And I believe that's about it. The archive is going to be uploaded on Canvas, and you'll see this video pretty soon. I will see you next time.